talk about distributions. So we're going to start off with a review. So orange M&Ms. Every student in class gets a little snack pack of M&Ms. Rob opens his M&Ms and has 8 orange out of 14 in his snack pack. According to Bob's sample, how many orange M&Ms should you get in a party bucket of 850 M&Ms? So we're going to do a ratio here. We're going to have orange over total equals part over whole. So we've done this before. And let me use a pen. So we're going to have 8 out of 40 equals x out of 850. And then we just cross multiply. Okay, so we have 8 times 850 equals 6800 equals 40x. And then we divide by 40. So we get x equals 170 orange M&Ms. So if you want to, whenever you can add a unit, you should. So our units are orange M&Ms. All right, so this is a review. We've done these ratios before. Here's another review. Satisfied customers. Telecom surveyed 500 of its customers and found that 42% are satisfied with their service. If Telecom has 8,400 customers, how many are satisfied with their service? So we want to do, this is pretty much asking what is 42% of 8,400. So that 500 is a trick number. They're telling you that they surveyed the 500, but they already gave you the percentage, so you don't really need to use the 500 at all. So this is back like 9.2, right? We have percent over 100% equals is over of. So we have 42 over 100 equals what is, and then the of is the 8,400, right? So we have of 4,200. And then the percentage they gave you, so you know that's above the 100. Bless you. Okay, so we're going to multiply with our calculator. Cross multiply, our favorite. 42 times 8,400, we're going to get a pretty big number. 352,800 equals 100x. Then we're going to divide both sides by 100, which means we can just cross out these two zeros at the end. So we get x equals 3,528 customers. So based on the survey, we're going to deduce that out of these 8,400 customers, about 3,500 are satisfied, which isn't that good, honestly. All right, let's jump into distribution. So that's what this is called, right? Distributions. Okay, so we're going to make a dot plot. There's tons of different graphs, right? You've seen like a pie chart, like a bar graph. This is called a dot plot. So we're going to just take all of these students and fill it in with a dot. We're going to try to make them like evenly spaced out, like the one down here. So if we look here, we have a 20. We have an 18. We have a 21. Just add a dot there. If you see it again, you put it on top. So right here, we're going to put another 20 on top there. We have our first 19. Another 19. So try to make it right. See how the second of 19 is sort of in line with the second of 20? So try to fill out this dot plot along with me. Another 20, 21, 19, 23, 18, 19, and then 17. So your dot plot should look like this. And this is showing you like how common these are. So this is different students and the percent orange that they're getting, right? So you could see that most people are in this area, but we have a, like this, who is this? Billy Bob had a higher percentage of orange M&Ms. And then if we look at Baxter's class, we have a little bit of a different distribution. So something that you want to think about when you're thinking about data is that data can have different shapes. And by shapes, that another word for that is like distributions. So distribution is the way things are split up, right? If you're like, I distributed my birthday cake evenly, then everyone gets an even slice. Or you could say, I distributed my birthday cake where the older kids got bigger slices, right? So distribution means like splitting off, right? So these are distributions of data. This is different shapes of data. Okay, so if we look at this first one, we can see that it's sort of more like this like mountain, right? Like this curve. But if we look at Martin's data distribution or shape, it's sort of like two mountains. So this is what I mean by different shapes. All right, let's go to the back page. So these are the main three types of data distributions. So we're going to write them down. This one is called skewed right. This middle one is called normal. And then the last one is called skewed left. Then these two right here are not as common, but they're still nice to know. This is called uniform. And then the very last one's called bimodal. So skewed right, there's this thing called the tail, right? So tail's like the tiny part, right? You know, like think of a dog and its tail wagging. So tail is like the smaller part of the curve. I don't know if you want to write that down or if you just want to visualize it. The way that these are named, it's really easy to get these confused. So it's skewed and then where the tail is. So even though the big chunk of the graph is on the left, this is called skewed right. So just remember, like wherever the tail is, that's how you call it. Because I'm gonna give you a graph like this, I'm gonna be like, what kind is it, right? And you have to say skewed right. Normal is a normal curve. You might have heard of normal distribution. It's just like, you know, a lot of people in the middle and then some people in the extremes. So if you think of like, if you heard of IQ, like an IQ has a normal distribution. So most people are average and then some people are really smart and then some people are like really dumb. And then we have skewed left. So if you think about it, this would be like with the M&Ms, like some people having not that much orange, but then a lot of people having like a higher percentage of orange. So different distributions tell you different things. Like so for example, uniform, everything is about the same. So this would mean that like everyone was getting, you know, the same, like an equal distribution of the orange M&Ms. And then bimodal, these are like the modes. So bimodal is like, it's almost like two humps. I don't know. Right. So it'd be like we had a chunk of people, let's say this is IQ again. We had a chunk of people that were dumb and then we had a chunk of people that were smart and we didn't have that many people in the middle. So as you go through examples, you'll understand like what different data is saying, but you just want to know like how to name it. So if you're talking about it with someone, you could say, oh, hey, this data is skewed left. All right, so I want you guys to try. Not that hard. The answers are right on top. I want you to label each of these three graphs. You know, we have a bar graph, we have another dot one, and then they use X's to represent it, but they have the same idea. So try to figure out what those three shapes are. Okay, you guys did really well. This one has a little tail at the left. This is skewed left. This one has a nice normal curve. This is normal. And then this one has two little bumps. This is bimodal. All right. So that is it for the types of distributions. Not so bad, just some vocab, getting familiar with it, and then trying to understand how it connects back to your ratio reviews.